Hello everybody and welcome to another video from Carl's Tech Shed. Well, what I've got for you today is this. This is a Medtronic Carelink monitor. These are given to patients when they leave hospital after having a pacemaker or defibrillator implanted into them. What this device does is it allows the hospital to have a link of communication with the defibrillator or the pacemaker so that they can monitor the activity of the device and check on the patient remotely. This is generally used once every 24 hours by the patient, and what it does is it takes the information from the pacemaker via like an RFID system, like a wireless link, and then it's transmitted over the phone line to the hospital. So I can imagine this would be quite an interesting device to tear down, so I thought we'd take a look inside it. Well, on the underside of the unit we have a small label, and on this label is quite a lot of symbols and logos, so I'll go through some of these with you now. At the top here we've obviously got the Medtronic logo here, but below that we've got this CE logo. Now what's interesting about this is it's in a box and it has a number below it, which is 0123. What this means is that the device has been classified for use as a medical device. Next to that we've got the IEC 60601-1. Again, this is a medical document related to devices designed to be used on patients in hospitals, and basically anything medical has to comply with these regulations. And next to that we've got another N13571, which is more classification and regulation you need to design medical devices. Below that we've got the part number. We've got this small logo here which has an AC symbol, a DC symbol, and a small box around it with a line through it. I've seen this before. I can't find any information about it immediately, but it basically means that it has an inverter inside it which converts AC to DC. Now although this runs on DC, it does have a phone line input, so it could be for that. Underneath that we've got this other symbol which is two boxes, one square inside another square. What this means is that the device has been doubly insulated. This means that even if a cable inside it were to come in contact with the internal casing, it would not cause any harm to the user because the casing is plastic, so it's non-conductive. Next to it here we have an exclamation mark above a manual, which basically means consult the manual before you use this. You see this on a lot of electronics these days, which are quite complicated or has to have a certain use. And below that we have a little stick figure. Now I wasn't actually sure what this was at first, but I've looked it up, and this device is actually type BF classification, which means that this is certified to come in contact with a patient. This is sort of a mid-range classification. There is higher than this, which is CF. It's the most stringent classification. This would be things like pacemakers and defibrillators and things like this, but because this only picks up a signal from the pacemaker, it doesn't actually require as stringent testing as a CF classification device. And finally below that we have a WE symbol, which basically means it can't be discarded in household waste and it has to be recycled properly. So that's pretty much all of the logos and symbols on here. So I'll open the case up and we'll see what's inside it. Okay, well on the front of the device, as you can see, all we have is a single button and a series of LEDs. Now the reason this has been designed like this is to make it as simple to use as possible for the patient, because you have to remember a lot of these patients are going to be having these devices fitted. Some of them will be quite elderly, so they may not be confident using a device which looks quite complicated. So because this is being used at home, they may even try to avoid using it, and that wouldn't be very good for the hospital or for the patient if they were scared to use the device at home on their own. So all we've got is a single button, and we've got a series of LEDs which shows the progress of the data transfer. Now what we've got in here is a small pad, and I think I see now the reason why this has been discarded and written off by the hospital originally, because this is snapped off. So obviously you need to put your finger under there like that and hold it on your chest, but if that has come off, it's going to be quite difficult and maybe quite dangerous long term if somebody were unable to use this. And what we've got in here is just a small induction loop. So this would pick up the data from the pacemaker or defibrillator which had been fitted into the patient. So they'd hold this up to their chest, and it's just a shortwave radio communication through an RF loop. So that cable goes into here. It's quite long. It's probably about 6 foot, something like that. So it's certainly long enough to be comfortable to use sitting down. So if we turn this device around, one other thing I'll just point out is that this is relatively modern. The date code is the 22nd week of 2012, so it's quite a new unit. It's just being discarded probably because this little band has come off, and they just decided not to repair it, or they're not allowed to repair it. Obviously, being a medical device, it's probably very stringent classification and regulation to prevent you from repairing these devices for obvious reasons. So if we turn this round, what we've got on the side here is just a couple of buttons here. Now these are the only buttons which are on it, and these are all to do with the type of phone line it's going to be using. We've got either tone or pulse dialing depending on what part of the world you're in, and then we've got a series of numbers. I looked in the manual online, and what this is, it's for if you need to dial a number to get an outside line. So obviously, if you don't need to dial a number to get an outside line, you select N. If you need to dial 0, 8, or 9, you select one of these. Not really sure what they do if you need to dial another number. But I suppose that's the most common numbers you need to dial, either from a care home, hospital, or office if you need to get an outside line. On the back there's absolutely nothing, and on this side there's just a power input and a phone line input and a phone connection. Now I'm not sure exactly which one of these is going to be the phone and which one is the line, or whether it matters at all, but they've used the same symbol, so I guess that's just to make sure that the patient realises that they can use either of these connections to connect it to the phone line. It's just got a normal 7-volt DC barrel input. So let's open this up and see what's inside it. Right, well the first thing we see is quite unusual. We've got these two antennae up here. These are quite odd because I'm not sure whether you can see it on the camera, but the copper on this, the copper wire wound around this is a lighter colour, and this is more of a dark red colour. So I'm not sure whether they're using a different metal or whether it's just oxidisation or a coating that they've put on it. I'm not entirely sure why these are here, but we'll have a look at these in a minute. What I'd like to focus on is the input cable from here. Now we've got how many have we got? We've got 4 or 5 cables coming off of here, and they go into here. So this is going to be a digital RF frequency which is coming in. So we've got a couple of RF frequency processors here. This leads down into here, and eventually it comes over to this chip here. Now this is a Texas Instruments DSP, a digital signal processor. So what this is effectively doing is it's taking in the data from the pacemaker over the RF field. It's then processing it in here into a different type of digital signal. It's then storing it in the RAM, and then it's sending out the modified digital signal down the phone line through here. So effectively what it's doing is it's taking the patient's signal from their pacemaker, storing it, and then relaying it back through the phone line to the hospital. Now obviously I've looked in the manual, and this takes about 3 minutes to transfer the data from the pacemaker to the device, but then it can take up to 30 minutes to transfer it down the phone line. So I'm probably guessing that this is going to be this RAM chip is going to be storing the data and then reading it out bit by bit as it sends it down the phone line. These small chips here, we've got I've looked this up. This is just a basically like a modem chip which runs at 56,000 bits per second. So it's a 56k modem in effect. We've got a couple of 8-bit shift registers down here. We've got a 32 meg flash chip here. So this would be to hold the firmware for the DSP and the boot up sequence. All the LEDs are soldered onto the board. These are all surface mount. I don't think there's any through-hole components on here. Just the small beeper here and the switches. Everything else is surface mount. We've got a lot of capacitors here over this phone line. I think the reason for this is purely for safety, because obviously because the power supply is made by Medtronic, they can implement a lot of safety features into the power supply itself. Obviously you've still got a few safety capacitors here, but then obviously you've got no guarantee as to what the state of the phone line is like. So I think that's why they've got 8 of these high voltage capacitors over the phone line here. Now the interesting part about this, as I mentioned, is that we've got this large wireless looking section up here. Now I've looked in the manual, I can't find anything about this particular model being wireless or working on a phone frequency or mobile network at all. But what I did find was we've got some of these pin headers here. Now we've got exactly 6 pins here, 4 pins here, and we've got a switch over here which is not populated. There's a number of other components around the board which aren't populated either, namely this chip here. There's meant to be, looks like a surface mount chip here which is meant to be there. There's a series of pin headers which are meant to be fitted here, but strangely enough we've got all the capacitors and resistors which have been fitted here. Now if we have a look at the board itself, we can see a lot of clearance between each section of the board. So for example here, obviously because this is the phone line, we've got a large clearance distance between the phone line part of the board and the rest of it. And the parts which are connected are obviously connected through these high voltage capacitors. Now we've got another part of the board here. Now this is all separate. This whole wireless module is separate. The only data transfer or communication is done through this part here. So what I'm guessing is that this could have been for a different model, maybe for a different part of the world or a different country, where instead of using a phone line, they would have used a mobile network, because you can imagine them fitting a SIM card slot here. You could easily fit a SIM card slot into these, because 6 pins is how many pins a SIM card has. So that could be for a SIM card holder, and then the switch up here could well be for enabling the GSM module, because under these cans here, I'll take these off in a moment, these are probably going to be mobile sort of GSM and GPRS modules. I doubt it would be 3G, because the part of the world which is going to be using this is probably going to be either very expensive or very little signal for 3G, and because of the type of data it's going to be sending out, it's probably best for them to use GPRS or just GSM. So what I'm going to do is I'm going to take some of these cans off and we'll see what's underneath them. Okay, well I've taken the cans off this part of the board and I didn't actually find any mobile communication ICs at all. Instead what I found was a series of these radio frequency modulation and amplification devices. So most likely what this area is for would be for maybe a different model of pacemaker or defibrillator, which doesn't actually require the paddle to be held up to the patient's chest, so it would just communicate directly with it within a certain range, say 10 feet or something like that. And I think the reason that they're able to do that is because initially when this device is received by the patient, they have to register the device which has been implanted into them with this communication console. So they have to hold the paddle up to their chest for a certain number of seconds, wait until certain lights flash, certain colours and so on, to ensure that the device serial number has been registered. And after that time, this device can't be used with any other pacemaker or defibrillator. It would have to be sent back to Medtronic for reprogramming or to erase the serial number. Now initially when I read that, I thought maybe the serial number would be directly put onto a write once EPROM or something like that, but it turns out it's most likely just going to be software, because I've checked all the part numbers, there's no EPROMs in here at all. There's just a small 32 meg flash chip and a 64 meg RAM chip, so there's no EPROMs in here at all to hold the serial number. As I said before, we've got all the button, we've just got the single button here. We've got a couple of LEDs over here, which is a bit odd because there's no hole on the casing for them, so maybe that was an earlier revision or something which wasn't used. There's also a third switch here, it's marked switch 3, which is unpopulated. There's quite a lot of unpopulated components on here, so maybe this board was used for different models later and earlier models, so they just modified it and used different parts, because I can imagine trying to build one of these from scratch would be incredibly expensive because of all the regulations and such you have to pass with medical equipment before you can put it onto the market. One other thing, I couldn't actually find a cost of these. Obviously being medical, I can imagine it being quite expensive, but I needed to look no further than the underside of the label, where it says they're property of Medtronic Incorporated. So this generally, I can generally assume that this is not actually sold or given to patients, but it's rather loaned out to them. Whether they require them back or not is a different story, but for legal purposes they've just obviously had to put on there that these are property of Medtronic. But I'm sure if you try to return one, they'd probably just laugh at you or tell you to chuck it in the bin, because once these have been registered, it's probably not worth their time reprogramming them to use them with a different pacemaker. Also, the cost of manufacturing these, apart from the development cost, the manufacturing cost is probably going to be relatively low, so it's probably not worth their time to get these back and reprogram them. Well, thanks for watching the video, and I'll have something up soon. Please leave some comments, and if you've got any more information about this which I didn't cover, then please let me know.